An access code consists of one letter of the alphabet followed by 4 digits. Digits are numbers 1 through, or actually 0 through 9. How many different access codes are possible? All right, so let's think through this. Well, first of all, they're access codes, so order matters. So we're not going to use combinations. And we could pick one of the counting rules, but the fundamental counting rule is the best choice here because there are a couple of different conditions happening. One is that one letter of or the first letter, or the first character, I should say, of the access code needs to be a letter of the alphabet. And then 4 digits. So I'm just going to diagram this out for myself. I have one selection that's going to be a letter from the alphabet, 26 possible letters. Now I also have 4 digits. 1, 2, 3, 4. Okay, so my digits can be any number between 0 and 9. Then we have to ask the question, let's say I select 1 as the first digit. Can I use 1 again? Or do I have to do this without replacement? And if you just think of any time you've had to make a password or an access code, usually repetitions are allowed. And there's nothing else in this statement that leads me to think we have a restriction on being allowed to use 1 digit more times than 1. So, assuming that we can allow repetitions, then I have 10 choices for each of my 4 digits. So then the answer is going to come from multiplying 26 times 10 to the 4th power. So that will be 26 times 10 to the 4th power. So 26 with 4 zeros after it. And that'll be your answer. Here's a similar question. For some particular website, the password must start with one of the letters A through F. Then there must be 3 more characters, and each of those characters may be a numeric digit or a letter of the alphabet. How many different passwords are possible? So we have, let's try to diagram this out. We have there must be 3. It must start with one of the letters. Okay, so it's going to start with one of the letters A, B, C, D, E, or F. So there's 1, 2, 3, 4, 5, 6 options for that first character. Then there must be 3 more characters. Okay, the 3 more characters can be either a digit, so we know those are 0 through 9, so there's 10 digits, or a letter from the alphabet. So that adds another 26 possibilities for each one of these spaces. So the answer is going to come from doing 6 times 36 to the power of 3. Go ahead and calculate that. 6 times 36 to the power of 3 gives me this very large number, and that's that.